and happy Friday! Today you're going to be reviewing for your TEKS test. I know you've had one of these tests, DPMs, benchmarks, whatever they call it, in a lot of your classes. Ours in geometry falls on Tuesday. So you have 2 good days to get ready for this TEKS test in class. Today we're going to review the first half of the material, and we'll be looking at review page 1. So get that out if you've already looked at it, or get it out if you've never looked at it. And then on Monday you'll get one more full class period review so you can feel really good going into the TEKS test on Tuesday. A reminder that that is a major grade. It is a test grade, and so it's an awesome way to boost your average at the end of the 6 weeks and semester. Okay, so we're going to begin by just going over a couple of concepts. I'm going to work a couple of things, and then when I say, okay, now work on these problems of the review, you can pause the video and you can work on those problems and push play again. The very first thing that we learned when we got back from winter break was advanced transformations. And a big part of that was when a figure is dilated, we learned how to find the scale factor. Like, hey, describe to me how that figure changed. Did it get bigger? Did it get smaller? Did it get bigger by 1.5? Did it get bigger by 3? And so we learned that scale factor is always a fraction, and you always put the second figure over the first figure. So you're welcome to write that down somewhere. You can put that like in the notes on the side. Second over first. Second over first. Second over first. All right. So I want to go from A, B, C, D to A prime, B prime, C prime, D prime. So this one is my second, and this one is my first. I'm noticing right away that if I go from here to here, my figure has shrunk. It has gotten smaller. So my scale factor needs to reflect that, and we'll talk about that in a second. The great news is you can pick any point you want. You can work with A, B, C, or D. It does not matter. I'll work with C. The coordinates of C are 0, -3. The coordinates of C prime are 0, -1. We're going to put second over first. So I get to pick whichever number I want. In this case, I need to pick the y values. And second over first. -1 divided by -3. You can always ask your calculator if you don't know what happens to those negatives. So the scale factor, I'm sorry, there we go, much better, Miss Stanton. The scale factor is 1/3. Those cancel out, it becomes positive, and the scale factor is 1/3. Then it says write the rule. I want you to see what the rule looks like. The rule would be 1/3 x, 1/3 y. It would look just like that. So what happened to figure A, B, C, D? It reduced in size, and it reduced in size times 3. So that's why the scale factor is 1/3. When your shape gets smaller, your scale factor should be less than 1. All right, so let's try another one. Transform ABCD to JKLM and write the rule. Always stop and look at the picture. Hey, did my shape get bigger or smaller? Enlargement or reduction? And this time, totally enlargement going on here. This is figure 1 and figure 2. So I'm going to put second over first. This time I will do this value and compare it to this value. So I'm comparing D to M. D's coordinates are 0, 4, and M's coordinates are 0, 14. Second over first, second over first. So we do 14 divided by 4. We don't keep it like that because that is not a reduced fraction. So we divide that in our calculator. We do math, enter, and the scale factor is 7/2. You could also write the scale factor as 3.5 as well. Those are the same number. So the rule could be xy becomes 3.5x, 3.5y. That would be writing the rule. All right, last one. Describe 2 transformations that would transform ABCD to LMNO. We love our alphabet, don't we? All right, so I need to look at that rectangle I need to do two things to it, and when I'm done doing those two transformations, it needs to land on LMNO. What does your gut tell you? It's looking like we did a flip. The fancy word for flip is reflection. We reflected. Okay, what axis did we reflect over? Yell it out. What is this axis? All right, so step one, I'm just feeling that it's a reflect over the x-axis. All right, so when we reflected over the x-axis, we need to be careful. This segment, DC, was 2 away from the x-axis. If I'm 2 away, uh-oh, I land right here. That is not my final destination, right? So I need to do one more translation, one more transformation. We want to slide the shape and we want to slide it down 1. Sliding is called translating. Translate, down 1. So we reflected over the x-axis and then we translated down 1. That was 2 transformations that got us from our original, our pre-image, to our image. At this time, I would like you to get your review out and I want you to try number 2 and number 3. Please pause the video until most people are done with 2 and 3. Okay, now that you're done with 2 and 3, we're going to move on. The next thing we learned about were right triangles. We learned about right triangles. We learned how can you tell if a triangle is a right triangle. We also learned, hey, if I give you the side lengths of a triangle, can you tell me what triangle it is based off of its side lengths? And it all went back to someone very famous and their very famous theorem, our favorite one probably in the whole year, Pythagoras. It all came down to Pythagorean theorem. We learned that if if you write it backwards, very careful, to be careful. When you write Pythagorean theorem backwards, if c squared is greater than a squared plus b squared, your triangle will be obtuse. If it is less than a squared plus b squared, your triangle will be acute. And if it is perfectly equal to a squared plus b squared, your triangle will be right. So if I give you the sides of a triangle and I'm like, hey, which of these is a right triangle, you would be able to tell, but only by putting it into Pythagorean theorem. All right, so let's try it. I'm going to circle my largest number, and it happens to be the last one on each of these. I'm going to do c squared, and then a squared plus b squared. So go to your calculator. Everyone put your calculator in your hand right now. We all know what 5 squared is, right? So this is 25, and then 4 squared plus 4 squared is 32. 32 is the bigger number. So I put my sign like that. Now look at that sign. That is a less than sign. So the answer to A is, that is an acute triangle. It's so cute. Its angles are so cute because they're less than 90. All right, next one. C squared. Now let's compare it to a squared plus b squared. So we're comparing 9 squared to 5 squared plus 8 squared. We are comparing 81 to 89. And look at that. It is also less than. So it's also acute to acute in a row. Oh, this had a radical on it. And after I saved it, the radical disappeared. Awesome. It's there. That says 4 root 3, by the way. So if we're looking at this triangle, 4 root 3, 8. Before you start trying to square a radical in your calculator, do you notice anything special about those numbers? 4 root 3, 8. Does that ring a bell to any of y'all? X root 3, 2x. Do y'all remember that from special right triangles, 30, 60, 90? If you can look at those and you can know, oh, those follow the special right triangle rules. I already know that that's a right triangle. I know more about it, actually. I know exactly what its angles are. So those are the sides of a 30, 60, 90 triangle. That is on your formula chart. You don't have to memorize it. But let's pretend you didn't recognize that. and you went ahead and did what we did on our other problems. What you would need to be really careful about is you put 8 squared in your calculator, but then when you put 4 squared plus 4 root 3 squared in your calculator, be so careful to put parentheses around the 4 root 3. So I'm going to do 4 squared plus, I'm going to open parentheses, 4 square root 3. I'm going to get out of my square root. I'm going to close parentheses, and then I'm going to square it. I hope that y'all can see that. Let's see if it zooms in. Anyways, there are parentheses around that 4 root 3, and it's not focusing. But moral of the story is if you put that into your calculator correctly, you'll get 64. You'll realize that those are equal, and then that is why C is a right triangle. All right, I'm going to go through this pretty quickly because this is totally a review. We're still in that right triangle unit, reviewing over that one. Let's see. This is a right triangle, and I am missing one side. When you're missing one side of a right triangle, you use Pythagorean theorem, and you solve for x. A squared plus b squared equals c squared. So we'll go ahead and square those. Please do this with me. Please don't be just sitting there watching. Be an active learner. Get those calculators out. You get 2 of 5.25 equals x squared. The opposite of squaring something is square rooting. So the way to solve for this problem is to take the square root of 205.25, and you get 14.3. So that is the length of the hypotenuse. You can always make sure you did it right, because the hypotenuse needs to be the longest side of the triangle. If it's not the longest side, you might have done a step wrong. Uh-oh, solve for x and y. Well, I can't do Pythagorean theorem if I'm missing 2 sides. So this must not be a Pythagorean theorem problem, right? I do know that if this angle is 60 and this is 90, and I add those up and I subtract from 180, this one has to be 30. So everyone go to your formula chart, get your formula chart in your hands right now, and put your finger on the 30, 60, 90 triangle on your formula chart. Make sure you can locate it. Make sure you can find it quickly on Tuesday. 30, 60, 90. You can look at the rules. So it's x root 3, 2x. We were given the side across from 30. That's our x. We were given our x. So we can just follow the pattern. X root 3, 2x. X root 3, 2x. So I know that y is 7 root 3, and I know that x is 14. This will show up a lot on your TEKS test, on your final, all of the above. Last one, solve for x. Oh no. Can't use Pythagorean theorem because I don't have 2 sides. Can't use 30, 60, 90 because that angle is 23. Can't use 45, 45, 90. Do you remember what to use when you can't use any of those things? You're right if you said trigonometry. You use trig. Go to your formula chart and find where those trig ratios are. Look at that angle. Pretend you are standing at that angle. That's you. Hi, class. Happy Friday. Okay, that was a weird face. That's you. You're standing there. Compared to you, what is 6? Is it opposite? Is it adjacent? Is it hypotenuse? Compared to you standing at this angle, it's far away. It is on the opposite side of the triangle, so it's opposite. And then x, ooh, that's across from the right angle. That's the hypotenuse of the triangle. So I have opposite and I have hypotenuse. So go look at your trig ratios. Which one do you choose? Opposite and hypotenuse. Go find it. The winner is sine. So how do we write a trig function anyways? So you write the trig function, sine, cosine, tan. You always write the angle in parentheses. Sine of 23 degrees equals, and then the formula chart says opposite divided by hypotenuse. 6 divided by x. Then you ask yourself, where is my variable? Is it in the numerator or the denominator? And the great news is there's a little trick. denominator divide. So if it's in the denominator, that starts with a D, then you divide because that starts with a D. If it's in the numerator, you would multiply because numerator doesn't start with a D. So you go to your calculator and you type 6. Everybody type 6. Calculator, 6 divided by sine 23. So this might have been one that you're a little rusty on. What mode does your calculator need to be in for this? Everyone shouted, degree mode, right? You shouted it. So if you were in degree mode and you did 6 divided by sine 23, you should get 15.35 or 36 if you round. 15 point something. Okay, so that's trigonometry. Now I want you to try number 5 through 13 and only do the odds. 5 through 13, that's a lot of problems, so only do the odds. Please pause the video and come right back. Welcome back, guys. We do not have much more to go. Look how few problems are left on today's review sheet. All right, let's do a quick review of quadrilaterals and polygons. Do you remember the quadrilateral family tree? This might look familiar. A quadrilateral is simply a shape with 4 sides. So if you just say quadrilateral, there's nothing special about that other than, yep, it has 4 sides. What do the angles add up to in a quadrilateral? Do you remember? All the time, every time, the angles add up to 360 in a quadrilateral. Okay. Then we learned about some special quadrilaterals. The first branch that I want you to look at is the parallelogram branch. And I want you to have your review sheet out in front of you. And as I say properties, I want you to write some things down on your review sheet so you can get credit for it. Okay, write them down. And do so right here. Parallelogram. There were 5 properties of a parallelogram. There was a lot, okay, so let's talk about a few of them. First of all, opposite sides are parallel. That's in the name parallelogram. Something better be parallel if we're going to call it a parallelogram, right? Okay, so opposite sides are parallel. Opposite sides are also congruent. Same length, same length, same length as the opposite side. So opposite sides are parallel, opposite sides are congruent. The biggest one I want you to take away from today is that opposite angles were congruent. Write it down. Opposite angles were congruent. So angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. My picture got a little messy, so I wanted to make sure you understand. Opposite angles are the same measure, congruent. And then there was one more property, and it was that diagonals bisect each other. And I made my students like do the hand motion, but I'll write it down here because I ran out of room. The diagonals, that word means bisect each other. I'm not going to go into all the properties of the ones below, but let's go into the main ones. A rectangle, it's a parallelogram with 4 right angles. So he gets all the parallelogram properties, all 5 of those properties. A rectangle gets all of those. And then he's got a bonus for 4 right angles. A rhombus is like a parallelogram, but he got all of his sides trimmed up. So all of his sides are congruent. So a rhombus, it does not have right angles necessarily, but it has all congruent sides. Think of a rhombus as like a square, but he has bad posture. He's leaning over. His angles are not 90, but his sides are all congruent. And then a square, king or queen of the hill. Square has all of the properties, 4 right angles, 4 congruent sides. All right, what do you need to know about a kite? The main thing I want you to remember about a kite is that a kite always has a diagonal of symmetry. On that diagonal of symmetry, any part of the kite can look in the mirror and it'll see a congruent side. It'll see a reflection of itself. So when this segment looks in the mirror, it sees a congruent segment. So tick mark, tick mark. When this one looks in the mirror, it sees a congruent segment. So double tick mark, double tick mark. So kites have a line of symmetry. The same thing works for an angle. If I knew that this was a 100-degree angle, it looks in the mirror, oh, hi, and it sees a 100-degree angle. So it's like a mirror image. It's like you could fold it along the line of symmetry, and it would be copy-paste, the same exact on both sides. A trapezoid. Trapezoid only has one pair of parallel sides. That's really important. So it can't be called a parallelogram because only one pair of its sides are parallel. And then if it's an isosceles trapezoid, you get to put tick marks on the legs. Last thing I want to say about a trapezoid that we haven't talked about in a while is that if I draw the mid-segment, the way to find that mid-segment is you find the average of the bases. So you add the base 1 plus base 2, and you divide it by 2. So you might want to write that on your review. Base 1 plus base 2 divided by 2. Okay, in a math game, David was given the following clues and was told to guess which quadrilateral each clue is describing. Opposite angles are congruent. Okay, which ones is that true for? It's true for a square, true for a rectangle, and not true for a trapezoid. Ooh, true for a parallelogram, and true for a rhombus. That would be true for everything on that side of the family tree. Everything under parallelogram, that would be true for. Okay, oops. Next clue. Ooh, in this shape, the mid-segment is the average of the bases. Well, if you had to guess which shape, if you were playing a game, and you know it was like a speed game, you had to click it really quick, hopefully you would click this one right away. That's a trapezoid. His mid-segment is you add up the bases and divide by 2. That's what a mid-segment looks like if you forgot. Finally, which one will a diagonal, let's make sure we know what a diagonal is, will split the figure into 2 congruent triangles? A diagonal will split the figure into 2 congruent triangles. What do you think? Triangle 1 congruent to triangle 2? I promise you, it is. What do you think? Does that triangle match that triangle? If you rotate it, I promise it does. What do you think? Do those triangles match? Now, we're going to pretend that this one's not isosceles. And in a trapezoid that isn't isosceles, then no, it would not divide it into 2 congruent triangles. And in this one, even in this one, it doesn't either. Because look, this side is shorter than this side, so they can't be congruent. So either way, whether it's isosceles or not, it does not happen in a trapezoid. What about in a parallelogram? The answer is yes. I could prove it to you by congruent triangles side, side, side. They're guilty of being congruent by side, side, side. And then a rhombus, yes. So it worked in all the shapes except for that trapezoid. Okay, I want you to finish off your review. I want you to do these quadrilateral problems, 15 and 16, but then I want you to go back and do any problems that you have not done yet. Thank you. Have a great weekend and be ready to study a little bit more on Monday and take that TEKS test on Tuesday.